Hey, this is Joel Duff, and one thing that I do, for my job or on my job is I need to keep up with scientific literature. And one of the ways I do that is through Twitter. I follow a number of different journals and a number of different people that I'm interested in, topics that I'm interested in. But I also just go straight to different journals, maybe once every couple weeks, and I look at the most recent papers by various keywords. And I'm always struck by just like I always learn something new. I really enjoy that time. In fact, it's a time where I have to just tell myself, all right, I got to stop now because I'll just go down all kinds of rabbit trails, learning all kinds of new things. And I thought, you know what I'll take you on one of these little adventures. I'm going to take you to PLOS One, Public Library of Science One, which is an open access journal. And one of the reasons I'm looking at this one is because I know that any one of you out there don't need like special access to this particular journal. You don't need to be at you don't need to be at an institution of higher ed or anything like that to get special access to these things. Any of you could read these papers and any of you could look up stuff in a journal like this. And it's kind of a fun way to see like what's on the cutting edge, what's just coming out today or tomorrow. I've done a couple of videos on just like recently released stuff, like within the past day. This will be a little bit older than that. But let's take a look at, let's spend a couple minutes. We'll browse through PLOS One, and then I'm going to show you an article that I saw that's just published for the last couple of weeks. And then I'll show you what I do when I go look at articles and kind of like how I scan through them and what do I try to glean from those articles. All right, we've got that coming right up. Right, so here we are. We're back at the PLOS One page. Now, what I've already done is I have browsed, and I've browsed to a particular category because PLOS One covers pretty much the breadth of the natural sciences. And I've browsed to this category and paleontology. And I'm going to what articles in paleontology have been published in the last couple of weeks. Now, PLOS One is not exactly like super high tier. It's not even high tier. It's not even like middle high tier journal. It's a pretty average journal. They publish tens of thousands of papers a year. And there aren't going to be like any of like the huge, really big stories, right? If you got like this amazing story, amazing finding, it's going to knock your socks off. It's about some like brand new T-Rex and some awesome thing you discovered about them, like their vomit or something. I remember that was like a real sexy paper a couple of years ago. That actually wasn't T-Rex. That was some kind of sauropod. Anyway, the point is, if you had some really, exciting paper that was going to, make a big splash, PLOS One's not where you're going to try to publish that first, right? You're going to go Nature, Science, PNAS, you're going to put it in some more high-profile journal to get more attention. This is the more mundane science, right? These are graduate students have been working on projects that aren't like the flashiest thing ever, but they have collected data and you need a place to put that data. And I've published in PLOS One myself. There's some very decent articles there. Some really good information. I think there's also some pretty bad articles there too, because the amount of the peer review process is hit or miss. All right. And so there's some stuff that skates through at times that I kind of wish wasn't there. But in some topics like paleontology, and you're just describing fossils, this isn't a huge concern that there's going to be some terrible information in here that's going to lead everyone astray. All right, so here we are, paleontology, and I've sorted by, we're looking at cover pages just because I like to look at pictures versus the list, which we would be as informative to us. And I'm sorted by recent. And so this is the most recent article that just came out. Genetic diversity of wild ancient tea tree populations at different altitudes. I wasn't interested in that. I am interested in this one, the oldest known bat skeletons and their implications for Eocene Chiropteran diversification. Definitely going to have to check that one out. Landscape of mid-Eocene a snapshot of mid-Eocene landscapes in southern central Andes. Exploring the relative influence of raw materials, percussion techniques, and hominin skill levels on the diversity of the early Oldowan assemblages. All right, so that's about hominid evolution and their use of stone tools somehow, right? thousands of papers about that. And here we are at the one I'm going to show you, but which is this one right here. Unique trackway on Permian Karoo shoreline provides evidence of temnospondyle locomotory behavior. I don't know. Sounds really exciting, doesn't it? But I'll try to make it as exciting as I can when we go through that paper. You might wonder why did that catch my attention and not some of these others, which I haven't looked at yet. I'm always interested in trackways, and so I've read a lot of other trackway papers, and so because I have more background information about that, I can usually understand these papers a little bit, pick up on them a little more quickly. I also know about the Karoo Formation, which is in South Africa, and I've read other papers about that, and so that also attracted me. And I also knew that, my big interest is critiques of young Earth creationism. I knew just by looking at the picture, right, that I was going to be interested in this paper because I knew I was going to be able to comment on the fossilized ripples, water ripple marks, right? That's what you're seeing there. And I recognized that as soon as I saw that. That's rock that you're looking at, not like a sand beach. But what that is a fossilized beach. And there are apparently trackways on that particular beach. And it's not, actually beach is the wrong word, very shallow water. So like tidal pools or a very shallow lake, right? And you get these ripples on the bottom of the lake. And that's what you're seeing being preserved. And lake ripples are something that's very difficult to describe in a global flood of young Earth creationism, right? All this rock in the Karoo Formation, which is very old rock, according to conventional dating, would have all been laid down very quickly in a global flood. And so how do you get these types of things? And then when you think about, there's evidence of animals walking around on these or swimming right above or walking through this shallow waterway, well, that's adds an extra difficulty layer, all right, for young Earth creationists to explain. So that's a little bit of the angle that I'm looking at when I'm thinking about, am I going to be interested in looking at this particular paper? And so I'll tell you about this paper, and then I'll also tell you how I assess how that fits in with young Earth creationism as we look at it. Let's see what else is here, because I haven't looked at this other stuff. Evolution of the median fin patterning and modularity in living and fossil Osteochithians. I don't even know what those are, but some kind of fish, apparently. The other thing that caught my attention about the article we're going to look at is I didn't even know what temnospondyle locomentation. I didn't know what temnospondals were. I'm kind of embarrassed. I did know now that I've looked. It turns out I did actually know what they were. I just didn't know what the name of them was. All right, so let's click on this. All right, let's go here. So here we are at the article, and I'm just going to go ahead and bring up the PDF. Right, I think we prefer to look at the PDF. All right, so we got a couple. The authors here are from, it looks like, Institute of Witwatersrand in Johannesburg, South Africa, which makes sense since this is in a location in South Africa. And then there's a couple people from the Swedish Museum of Natural History and also the Natural History Museum of London. Let's read a little bit of the abstract. There's a gob of terminology in here. All right, there's lots of techno speak, and you'd have to know rock formations and a bunch about ichnofossils or ichnofossils and their terminology. And I'll just sort of give you a feel for some of it. But trust me, I don't know all the terminology in this paper, right? So there are all these papers here. You can open up each one. And if you're not a specialist in that area, there's going to be a bunch of stuff you don't know. But the challenge is to kind of like get the gist of the paper anyway. And hopefully the abstract will get us that. Large body, I can't even say that name, amphibians. So now that we know they're amphibians, were the dominant predators in non-marine aquatic systems from the Carboniferous to the Middle Triassic period. In the Permian age Lower Beaufort group in the main Karoo Basin, so that's where we're going to be looking at these fossils in a Permian age fossil bed, South Africa, temnospondals are represented exclusively by the family, and then there's this certain family of them, and are well represented by body fossils. All right, so apparently we have a whole bunch of skeletons preserved. All right, we have fossils of their bones, And enough have been looked at that we've recognized several different species, all of which seem to be closely related to one another and therefore placed in a single family of this particular group of amphibians. Whereas trace fossils are scarce, right? Now, when you only have bones and you don't have any other traces, and that would be other evidences of how they lived and how they moved, say. So traces are like footprints, right? Give you some idea of their locomotor ability. Accordingly, most interpretations of the behavior of this family are based on skeletal morphology and histological data, right? Just the bones. And so what do we know about the behavior of these animals? How did they move about? Did they live in the water? Did they primarily live on the land? Things like that. We might be able to tell that from other forms of data, specifically ichnofossils. Here we document the sedimentology and paleontology of the late Permian paleosurface. Paleosurface is an ancient preserved surface in the past, ground surface, or in this case it's going to be just below the water surface, situated immediately below the paleo shoreline of the Eka Sea, right? The name of the sea in that particular area, the time that's been given. So this is a paleo shoreline. So there is a shoreline, which actually is described sometimes too as a delta area from a stream entering into a larger body of water, potentially salt water, but probably brackish water or even fresh water. And that all comes from other data that you can look at in terms of the types of, well, that comes from the sedimentology, tells you what kind of water it was sitting in. Anyway, so this is a paleo just below the paleo shoreline, right? So you have the shoreline, and then you have shallow water, and these ichnofossils are going to be found on the surface of this paleo surface, just below the water surface. The surface preserves numerous ichnofossils, including tetrapod footprints and fish swim trails. So when fish are in shallow water just above the surface, right, the paleo, the old surface there, and they quickly swim by, all right, their eddy that they leave behind can actually leave marks in the sand, which are preserved in the fossil record. Yeah, believe it or not, we have millions and millions upon millions of swim trails in the fossil record. But most strikingly are 7 body impressions and associated swim trails that we attribute to a medium-sized 1.9 meter long. That's a pretty large animal, especially we're talking about the Permian now. This is before any mammals are ever found in the fossil record. This is before any dinosaurs are found in the fossil record. And this is really even before we have any significant reptiles in the fossil record. And so they think that is this thing called a tremenospondyle. I cannot say that word at all. So what is this organism? You're sitting here wondering, like, what the heck is that? So let's search Google real quick. All right, there we go. There is a temnospondyli type of amphibian. And look how large that amphibian is. And if you know your famous fossils, you'll recognize that looks a little like something. It looks a little like a Tiktaalik, right? Tiktaalik is that famous fossil from the Devonian. And once I looked at this paper a little bit more, I realized that the layer of rock they're looking at is not very much farther up from the upper Devonian layers. And so these organisms that we're talking about are amphibians that actually look a whole lot like Tiktaalik. And Tiktaalik is that fish-like amphibian, right? An amphibian, it has sort of legs but are still fins, and has a head shape, right, and a jaw shape that's much more like amphibians than it is like a fish. So it has a combination of characters of the two. Let's go to the Wikipedia page. I'm not a huge fan of Wikipedia for science, but I think for general information, this is pretty good. All right, so there's an example of a there's an example. So see, that's a pretty substantial organism. And the Wikipedia page, I looked at this earlier, right? These organisms They're a diverse order of small to giant tetrapods, considered primitive amphibians. It's an entire group of primitive amphibians. And they flourished worldwide during the Carboniferous, Permian, Triassic period. So during the 210 million years of evolutionary history which they are around, they adapted to a wide range of habitats, freshwater, terrestrial, even coastal marine environments. So apparently we have fossils from all around the world through multiple ages of this type of organism, all of which are extinct today. And then if I scroll down here, just to give you an idea what some of the other ones, some of them look like. Yeah, so as I scroll by here, you can see there's a bunch of possible recreations of what they may have looked like. And a lot of these have these long tails, and that long tail is going to be significant in the ichnofossils we're going to look at. But the other thing to notice is classification. So here's a group of amphibians. I've never known a whole lot about amphibians, and this is what's great about, spending a little time every week, just like, hey, what do we know? What's new? Is you always learn something new. I learn about a new group of organisms I didn't even know existed every single week. And here we have a large group of things. But a large group, this is considered to be a whole order, all right? A large grouping that includes multiple clades, families, right? Look at all these different families that have been named from different fossils. And then within each one of these fossils, you can go and take a look at what do we know about that family. In some cases, some of these families have multiple species or a couple different genera that have been identified from the fossil record. I counted up about 47 families here. 47 families of these amphibians, right? Remember, answers in Genesis, a young earth creationists, they kind of think of family as a kind, like God created individual kinds of things, right? And separately from other things. So if they're going to if they're going to consider a family a kind, then we're looking at 47 different kinds of amphibians here, all of which are extinct today, right? None of them exist, and they only have ever been found sort of low down in the fossil record. They lived up until in through the time of some of the dinosaurs, but disappeared before even the dinosaurs disappeared. That's an incredible amount of diversity, and found on every continent. All right, so again, here's giving you an idea on the side here of the different kinds of things, all right? Very large amphibians. Of course, today, what do we have? We've got frogs and salamanders, right? And there is that giant salamander in China, which is pretty hefty organism, right? A couple feet long. But here we're talking about potentially up to 5 or 6 feet long. Of amphibian. Okay, we're back at our paper. So we were asking ourselves, what are these things? And we were saying that, that this particular area, this particular layer of rock seems to have multiple members of just one family of these, right? And just out of the 47 families that existed over the earth. Of course, those families didn't necessarily all live at the same time. Right? In fact, you would say they wouldn't. If they're spread over 200 million years, some of the families might have had members, but they only lived for 15 million years. And then there's other families that formed from some of the members of that family and so forth. And so the families are even spread out over 200 million years. So at this particular location, right, you would expect to see a wide range of these different amphibians. You see, these are the types of amphibians that lived at that particular moment in time. Now, let's get down to the figures, right? I'm not going to read this paper, right? I'm not going to sit here and read it to you. We're just going to look at kind of a snapshot of like just a point in time, some research that a bunch of people have been working on at a particular location, and here's the things they found, and here's how they're reporting them to us. And this is the kind of thing that if you look in the literature, you can see about really every single day, right? You can find out something new about the world in the fossil record. All right, so here's the location in South Africa. They're showing different rock units and their ages that are expressed at the surface. And so they're saying, okay, in this particular layer of rock, this Waterford Formation, which is one particular layer in this Permian rock, it's broken down into a whole bunch of different layers. So there's intermittent mudstones along with sandstone. So sandstone would be you've got much faster moving water carrying down larger sediments, particles from upstream for whatever stream is feeding into this lagoon or this lake area. And then you have times where it's fairly quiet, right? You probably don't have a lot of deposition into the lake, and you just have very fine material that's falling out, and that forms these mudstones and shales. And then you might have another storm, and then you have more thick layers. And this also might be also changing climates over thousands of years, causing changes in the type of sedimentation occurring there. And all these little things on the side here represent right, bones, trackways, leaf impressions, vertical burrows, fish scales, and so forth. Those are the types of fossils that are being found in this particular sedimentary layer. Okay, let's get to the site. I got some great images, and that's one of the reasons I picked this article out, is got some nice images of the fossils. So here we have obviously a drone shot showing an area that has been scoured off. All right, this is probably there's just a little bit of exposed rock. Somebody noticed there was some fossils there, and then over a period of many years, they have been gradually, uncovering this particular layer of rock. Now remember, this particular layer of rock hasn't been, at the surface for the last 100 million years or anything like that, right? It's been buried in what was many layers of sediment above it that eventually have eroded, finally exposing this particular layer that's very ancient. And I don't know if you can see it from there, but you might not be able to see this well, but this white outlined areas show these weird streaks on the rock. And that's where they're going to say there are these large-bodied amphibians that are in the water, and they're propelling themselves in the water and also touching the paleo surface, all right, or the original surface then, with their feet, all right? So they have actually the foot marks and then also their tails, which are propelling themselves, and that's the ichnofossils, right? Not the actual body themselves being found, but the evidence of how they moved above this water. And you can see a bunch of other impressions here. These are all lots and lots of little tiny footsteps from that and from amphibians and potentially some other small animals. All right, and I want to show you this image right here, F. All right, F shows, they're looking at one layer, say this particular top layer, but there are many, 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 many different layers, all right, of mudstones. So typically sort of sand material or sandstone, and then maybe a thin layer of mudstone, and then another layer of sandstone, then maybe a little, maybe a thicker layer of sandstone. You can see there's different thicknesses. And so that might represent different big events. It might be a single event, like very large storm, but also might represent seasons, or might even represent, most likely actually probably a decade, all right, potentially, of material being laid down. And then, because the mudstone is different from the sandstone, it tends to separate and erode in these flat portions. And so it's on the flat surfaces then that we find these ichnofossils. And so undoubtedly, right, there are many, 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 many more ichnofossils yet to be exposed, right? We can only just look at this main surface layer that we have now, but if you chip that all up and looked at the next layer below it, probably is another series of ichnofossils from the period before that and the organisms living there at that time. These other images are showing things like ripples, right? These are sand ripples. These are very clear water ripples. Yeah, here we go. Right? Look at all these beautiful sand ripples. Right? And they've measured the distance and the width and the height of these. And then from that, you can do various calculations as to the motion of the water. Oh yeah, what about this A right up here? This is a great shot. You see this little very thin layer on top, which is kind of harder here? That's the mudstone. Right, so that's finer particles, and they have cemented themselves together in a much stronger way than the sandstone below, which is why you're seeing those ripples actually preserved in this particular case. You might well, how did ripples get preserved in the past? Aren't those very sensitive things? Well, yes, they are. But if you're in a shallow water body, you have these ripples form. right? Especially if it's in a somewhat tidal area, or maybe an area where a lake that is going up and down seasonality, right? And you have those ripples there, the water goes down, they might nearly dry, and then maybe the lake begins to fill up again because of a large storm, and that water fills up and it actually gets fairly deep, several feet deep, and it's filled with sediment, and the sediment starts to fall out. It's going to fall out on those ripples, and then what do you know? You've just covered up those ripples. And then that compacts, solidifies, hardens, and because you have another layer of mudstone on top, after the heavier sand grains fall out, then you're going to have another break point when you eventually turns into rock. And so you get these layers separated at that time. So you have these beautiful ripples formed. As I said before, you can do measurements of the ripple angles and widths and so forth and get an idea of like which way was the water flowing or which way was the water moving in and out and all that. And you can look at that at different areas. And when you do that in different spots, like, if you have another area where this same rock is exposed, maybe 100 yards away, and you see the ripples are in a slightly different direction there, you might get some idea as to like, oh, what was the shape of this lake? And, what was the depth right here? Different depths are going to lead to different ripple sizes. Now, let me just quickly comment here about, say, young Earth creationism. I want to remind you that all these rocks, right, all these layers of rock are laid down at a time. Here's some more. These are all laid down, stacked upon each other, presumably over a period of just a few days to a few weeks. This is really deep in the fossil record, and all this stuff is presumed to be laid down by a global flood. That's what young Earth creationists would say, right? If all this stuff's being laid down super quick, and you have layer after layer after layer after layer, and each of these layers has these fine ripple marks on it. Ripples, these fine ripples, do not form in sort of like chaotic waters, right? Fast-moving waters. This is lakes, right? Undulating lakes with wind on top, creating slight eddies in the water. And that eventually causes these ripples to form. And in this case, you have the ripples form, and then you have new sediment layer on top of that, and you have more more ripples form. And then you have another layer of sediment on top of that, and more ripples form. You do this over and over and over and over again, and there are areas here where there's probably 100 different layers of this type of stuff, right? And each one of them is formed in not a chaotic way, and they're thin pancake layers over large areas. How are you going to do that when you have to flood the entire Earth, and you're flooding this particular area with massive amounts of sediment that presumably are all just kind of like stacking on top of each other, one after each other, minute after minute, right? These types of fossil sites just make no sense in that model at all, right? And that's the thing that if you're a paleontologist or somebody in this field and you are actually looking at the literature, you're looking at this type of stuff every day. And then you hear young Earth creationists, oh, yeah, see, ripple marks here. If you go out in the ocean, and you can find ripple marks right out there, and you can find ripple marks in lakes. Of course, they're not going to really look at lakes because there wouldn't have been really lake environments during a global flood. But in the ocean, you can find a type of ripple, even in the deep ocean. But you don't find stacked layers of ripples, right, one after another. And you don't find them being preserved in the same way that you would in these shallow lakes, where we can see even today ripples being preserved in many different places on this earth based on present day conditions, right? So this is all stuff that we see as things that happen today and don't require some sort of large global flood to cause. Now that's just the ripple marks. Just the ripple marks themselves are just like flood geology doesn't work. It just doesn't. It's a non-starter in terms of explaining locations like this. But now we're going to add in ichnofossils, right? We can see that fish were swimming around on top of these ripples, right? And we can see that there were amphibians here. And there are some leaf impressions and so forth. And we add up all the fossils. All the fossils are unique, right? They're nothing like anything that's alive today. They are part of a unique flora that's only present at this particular time slice, right? Which these layers of rock represent. And now what you're looking at is you're seeing these weird impressions that were made in the ripples, right? The ripples are preserved, but they've been damaged in a way. And what could cause these scars in the ripple? And these are large, right? You can see this hammer here. These are fairly large. And what they're suggesting is that these are places where these animals, I'm going to come down here. Let me show you another one here. Here they're saying there was an amphibian that was basically resting its body in this shallow water body right here. And then there was probably another one right behind it, or either that or got up and moved and rested there a little later. Oh, I'm sorry, those are other tracks. There's lots and lots and lots of different fossils at the site. Okay, I like this. This one is better. This is the one I wanted here because here's the amphibian. Here's the type of amphibian that is found, the family of amphibians of this particular extinct group that are found in these particular types of rock layers of this age in South Africa. So we have body fossils, meaning we have bones, right? So we can recreate, this is the type of organism that existed in this area. And what they're saying is we don't have the bones right here, so we can't be absolutely certain. We can't be absolutely sure that this is the organism that made this. However, this is the only type of organism that is preserved in the rocks in this particular region at this particular time in history that is this size, right? These amphibians would have been the largest animals of the time. Largest land vertebrates of the time. And so what they're drawing the connection to then is, okay, here's all this other fossil evidence, and now we see, we see these weird marks. We've noticed these for years as we've been studying other things, and we were trying to explain them, and we drew the connection. Like, look, this is the most probable explanation, without having any more data that suggests otherwise, tells us that these are probably body traces of an animal that was laying on and disturbed these ripples in this shallow water. Over here on the right side is this is the mark of a alligator, right? On the surface of this is a lake that an alligator was sitting on and suddenly moved, right? Left this impression in the mud. And then the lake drew down, and that is the surface that's left, right, as it's drying out. Potentially, if the water refills after this dries and lays down another layer of mud, there will be a preserved ichnofossil, all right, or the beginnings of an ichnofossil. Will have turned to rock yet. But there is a preservation of evidence that a alligator once laid right there. And over here on the left side, that is what's seen in the fossil record from 220 million years ago, is this impression. And the other thing that's there, which is hard to see, but these are actually footprints, right? We've got some actual footprints there. And so we have this animal sliding along, pushing its way along. But then the other thing they note is, and I don't think you can see it on this one, in other ones they have kind of a wider area that's flat behind the animal where its tail is. And they think that this is the undulating motion of pushing through, all right? That in this water, the water is maybe deep enough that the animal is swimming. And the way it swam, based on looking at, I think it was like 16 or 18 of these ichnofossil traces of the body and feet, is that they imagine that it has its paws and its feet, and it's able to touch the ground, right? But the way it's moving, it's not pushing off. And how would they know that? Because they can look at the footprints, and the footprints don't always, sometimes they do, in some of them, but some of them, they don't push the sand back. It's as if they're just kind of touching, right? As if the body is moving, and then the feet are just kind of touching along the way. And how would the body move if the arms and legs, or the legs, aren't the ones that are propelling the body? Well, it must be the tail. And a lot of these amphibians of this particular group have these large tails that they think were very tall and essentially acted as a propeller, right? Not a propeller, but a side-to-side motion that is then pushing the animal through the water. Let me see if there's another figure in here. I thought there might be one other figure. All right, so let's just go back up here. There's a bunch of other ichnofossils here. I like this picture because it's a drone image of these two individuals standing next to and on this rock, and they're examining this ichnofossil here. So it's just, again, giving you a size for this. All right. Yeah, that's really all I've got. I just want to introduce you to a whole new group of amphibians that I discovered by doing this. And so amazing. Like 50 different families of amphibians, one particular family living in this particular area. There's this interesting site that has really fantastic preserved ripples. And then on those ripples are fish traces. I didn't really show you that they don't have any pictures in here of very clear fish traces, so I'm not going to point those out. But marks that are distinctive of what we see even in today's fish as they are swimming in very shallow water. And so preserved fish traces, and then there's leaves and there's other things. Apparently there's multiple other papers that have been written based on the other ichnofossils and fossils that are found at this particular location and other rocks in this particular area. So this is a well-studied area of this particular time period. And again, we're getting a slice of life when you do this, right? Getting a slice of an image of what life was like in the Permian age, right? In what is today South Africa. And I'll just stress one more time that this is something that, young Earth creationists have very generic, overgeneralized explanations for phenomena in the fossil record, right? They'll say like, oh, all these, there's so many fossils in the fossil. Well, that all comes from a global flood, because how else could they get preserved? And then ichnofossils, you might wonder, like, how do they explain ichnofossils like footprints? Oh, well, there was the water was going over the earth, and then, there were animals that were on rafts of vegetation or swimming, for several days and were still alive. And then sediments were piling up, and then maybe the water, as it's sloshing around the earth, kind of exposed some areas of sediment, right? And the animals that were, had been struggling to stay alive managed to climb themselves up on these sediment surfaces. And then they were running away, right? They were running across these surfaces, and they left footprints, and then more sediment was laid down and they got preserved. I think it was, all right, so that doesn't sound plausible at all to me, right? I think anyone who knows the fossil record at all thinks that's absolutely ridiculous. However, to a naive audience, it sounds like, oh, I guess that's possible, right? That animals would have been trying to survive and therefore would have left a lot of footprints as they tried to escape the flood. But then you just go to a site like this. I should be showing you pictures instead of just text while I'm talking. Then you see like this image F, and you see like there's multiple layers, and it's very likely, I don't know in this location, very likely in this location, but I don't know for certain. But I do know of other locations where there's 15 or 20 or 30 layers of sediments, and on each sediment layer there's footprints, right? And so this is much more easily explained as an actual location, like there are locations today where there are beaches or shallow lakes that are drying, refilling, and drying, and refilling, and drying, and refilling, right? Each time laying down new sediments, and then there's animals that come to the water hole and leave their footprints behind, and they get covered up and preserved, right? This is not a difficult scenario to understand just looking at the way organisms and the soil environment interact today. This does not look like a global flood. It does not look anything like what the description of flood geology is when you see these types of fossils. And this is just a tiny snapshot of one little tiny place in time, but there are thousands and thousands of places on Earth that have things like this. Different patterns in different places. That's the other thing about global flood geology. You would think that the geology of almost everywhere on the Earth would be kind of similar to each other if the whole world were flooded at one time and sediments were laid down all over the Earth. But we have very different sediments with very different fossils in different locations. All right, just a quick tour of PLOS One. And I just looked at the first page, 7 different articles. I opened up 2 of them. This was one of the 2 that I opened up. There's 4 or 5 more pages I could go to look at what I haven't looked at in the last month or 2. And so there's all kinds of more things to learn. Plus I could go to PNAS and I could go to a bunch of other journals as well. So there's just, it feels like infinite amounts of things that one could learn just from the published literature. It's obviously not infinite, but it's way beyond my capacity to ever take in during my entire lifetime. And that's kind of great because it just means there's always something new to learn. Any one of you could do this, right? You can go to PLOS One and just scroll through the articles until something, catches your fancy. It's like, well, what's that about? What's that particular organism? I'm interested in that place in the world, and this is something else I can learn about it. So happy hunting on your exploration of science. And we'll be back. I'll do this again sometime. I'm going to try to do more of this kind of thing, which is just kind of like my first look at new papers, new publications. How do I look at them, and what do I get out of them? What do I learn from them? Right, we'll talk to you later. Bye-bye.